Hey there folks, Mr. G here with another educational video. Today we're going to be talking about one of the most famous equations in all of math, one that you might have heard of before, but you might not have heard of either. It's called the Pythagorean Theorem, or Pythagoras' equation, and it's all about the side lengths of right triangles. If you forgot what a right triangle means, that just means that one of our angles here is equal to 90 degrees exactly. Now this comes up in a lot of places. One of the most common places that you would see is in architecture or in buildings. And in this picture of our bridge here, we can see there's a lot of right triangles. There's one that I've drawn in green, for example. Now the key insight for the Pythagorean theorem is imagine that you were building this bridge and you knew that the top of this bridge you wanted to be about 4 meters tall, and each of these sections you wanted to be 3 meters wide here. Then imagine you were trying to cut out these pieces of steel, or maybe order these pieces of steel, and you didn't know how long this section should be. If you know you want each of these supports to be 4 meters tall and each of these sections to be 3 meters wide, how long should you cut this piece of steel right here? Well, the equation that Pythagoras came up with, if we label each of our sides for the triangle A, B, and C, the equation that we get is that a squared plus b squared is equal to c squared. This is the really famous Pythagorean theorem. One thing that's really important to remember is that this only works for right triangles. Now you'll notice here that this side across from these two is sort of special, right? Because it's the one that appears on this side of the equation, and this side across from our right angle has a special name. It's called the hypotenuse. The other two sides, A and B, these are called the legs of our triangle. And you'll notice in our equation, if we swap A and B, a squared plus b squared plus a squared doesn't make a difference. So whether you label this one B or this one B, it doesn't actually matter. The one that's really important though is that the one across from your right angle, this hypotenuse, this one is called C, always. Another way that we can understand this Pythagorean theorem, a squared, b squared, and c squared, is by drawing squares on the side of our triangle here. If this is a square right here, that means this side is C, that means this side is also C, so this area would be equal to C squared. This side is A, this side is also A, this area would be equal to A squared. Same thing over here, B on each side, that tells us the area is B squared. So another way we can represent this equation is by saying the area on these two sides of our triangle here, so a square drawn on this side plus the area of the square on this side is equal to the area of the square on this side. So when we add these two areas here, we get the area of the other side over here. Now you might be thinking to yourself, wait a minute, how do we know that this is true? You kind of pulled this out of nowhere. Well, there's actually a lot of different ways we can prove this theorem. Proofs go all the way back thousands and thousands of years to Pythagoras. I think it was around 2,000 or 3,000 years ago. And since then, there have been hundreds of different ways to prove this theorem. I attached two videos. The first video, the TED Talk one, at about 2 minutes, goes through one of my personal favorite versions of the proof. But there's another one that involves water, and there's tons of other ones. There's whole websites devoted to different ways to prove this theorem. So if you're interested in that, I really encourage you to take a look at those videos and maybe try and find some other proofs that you like as well. For now, let's see how we can use this equation right here to solve our bridge building problem. So this was our setup for the bridge building problem, and we want to know how long we should make this steel support. The first thing that you want to do in any of these problems is to make sure that you label your sides. The only one that's super important to label correctly is this one right here. This is our hypotenuse. That one is always C, the one that's across from our right angle. And then for these two, you can call one A and one B. It doesn't really matter which. Just don't call them both the same letter. Our second step is to use the formula. So in this case, we have a squared plus b squared equals c squared. And what we're going to do is put in all of the numbers that we know. A squared, right? We know a is equal to 4, so a squared would be 4 squared. B squared is 3, and we're going to square it. And then c squared, we don't know. Now we talked about squaring and square roots last time. 4 squared is 4 times 4, which is 16. 3 squared is 3 times 3, which is 9. 16 plus 9 gives us 25. And now in this last step, we know that some number squared is equal to 25. Well, from our last lesson, that would tell us that this is the same as that number being equal to the square root of 25. This question asking what number times itself gives us 25 is the same as this question right here. A square root is what number times itself gives us 25? And in this case, if you remember your perfect squares, or if you just want to plug it into your calculator, you'll get that c is 5. So that tells us that this side over here should be 5 meters. And now you can build your bridge. Another way that we could approach this problem is by drawing squares on all of our sides and figuring out what these areas are. This area would be equal to 4 times 4, which is 16. And then the units for area would be meters squared. Meters times meters gives us meters squared. Same thing over here, 3 times 3 gives us 9, and our units are meters squared, because meters times meters gives us meters squared. Now from our picture above, remember that we can add these two areas together, and that should give us the area of this square right here. 9 plus 16 would give us 25 meters squared. And from that point, now we know that the area of a square is equal to 25 meters. So this side right here should be equal to the square root of the area, which we know needs to be 5. So that's another way that we could use a picture instead of the formula to solve the same question. One thing to keep in mind here, all of our lengths are in meters, which means all of our areas are in meters squared. So if we have a length in meters, our area would be meters squared. If our length was in centimeters, our area would be centimeters squared. If our length was in feet, our area would be in feet squared. All right, let's try applying our knowledge to a new problem. Remember that if we're trying to figure out the side length for our triangle here, we've got these squares drawn on all of our sides. If we want to figure out the length of one of these sides, that's the same as taking the square root of the area for our square. So the square root of 196, you can check using perfect squares or using your calculator. This should be equal to 14. So in this case, the length of this side would be equal to 14 meters. For this side, the square root of 121, that comes out to 11, so 11 meters. And then over here, the square root of 64, that would come out to 8 meters. What if we wanted to find the perimeter for our triangle? Well, perimeter is just all the way around, so it would be 14 plus 8 plus 11. So that would be 22 plus 11 gives us 33. Finally, is this triangle a right triangle? You'll notice that I didn't draw a right angle at the corner here. I didn't draw a right angle, so I could have drawn a question mark or something else. Is this in fact a right triangle? And how would you check that? One of the best ways to check it, since we know the area for all of the squares on the sides here, the visual version of Pythagoras' theorem here tells us that these two smaller areas should add up to the bigger area. So if this is our right angle over here, our hypotenuse side, that's the longest side, and it's always going to be the longest side, does this area equal to the sum of these two areas? So if we add both of these on this side, we get 185 meters squared, which is less than this. And since they're not equal, that means it's definitely not a right triangle. If you were stuck on this question and maybe not sure which one the hypotenuse is, remember, the hypotenuse is always going to be the longest side of this triangle. And that's because the hypotenuse has the largest area for these squares. The largest area means that it has the longest side. But in this case, since the area of these two sides doesn't match the area of this, we know that it's definitely not a right triangle. It's some other type of triangle. All right, folks, let's check your understanding. 3 questions up here. Grab a piece of paper, pause the video, try them out for yourself. All done? All right, let's go over the answers. For our first one here, we want to check to see if it's a right triangle. Now, we've done this already, but this was using areas. Now we only have the side lengths. If we have the side lengths, the easiest way to do this is to use Pythagoras' equation, but before we can use it, we need to label our sides. We know that the longest side has to be the hypotenuse if it is a right triangle. The longest side is this 8 here, so this has to be C if it's a right triangle. We don't know if this is going to be true, but if it is true, that means it's going to be a right triangle. For our other two sides, we can just give one A, one B. It doesn't matter which one we put as A or B. And then we're going to plug it into this equation and see if it matches. So there's all our numbers plugged in. 6 squared is 6 times 6, which is 36. 4 squared, that's going to be 16. 8 squared is 64. Let's add these two together, and we'll get an answer of 52, which is definitely not equal to 64, so this is not a right triangle. If they were equal, that would tell us that it is a right triangle. For our question here, we know that the legs are 8 and 15. And if we remember, the legs, those are like our A's and our B's. So if we were drawing this triangle out, we would get 8 meters as our A, 15 meters as our B, and we're solving for this long side, which is our hypotenuse, which is C. Now, it doesn't matter which one I call A, which one I call B, but we need to make sure that we're solving for our hypotenuse, which is C in this case. Again, we're going to use Pythagoras' equation. We can plug in our values for A and B, square these, add these two together. Then this here, asking what number squared is 289, that's the same as saying that our number is equal to the square root of 289, which if we plug into a calculator, gives us a side length of 17, in this case in meters, so our answer for the hypotenuse is 17 meters. For our last one here, we're trying to find this missing area. Since we already have it in area, and again, we're solving for the hypotenuse here, what we would do is we would add these two areas together. 25 plus 100 gives us an answer here for our area of 125 meters squared. So that's the answer for part A. For part B, we want to find the length of each side, which remember is the same as taking the square root. So in this case, the side length here would be the square root of 25, which we know is 5 meters. This side right here would be the square root of 100, which you might know is equal to 10 meters. Over here, we get the square root of 125. Now, it might take you a second, but you might realize that this is not a perfect square. If you plug it into your calculator, you will actually get a decimal here. You'll get a decimal like 11.180339, and then it would go on more, but again, your calculator might cut you off here. If we're rounding to one decimal place, that means it's going to be a 1, but since this number is an 8, we round up. So our answer would be about 11.2 meters for this last side. That's the end of the video. Make sure that you check out some of the homework problems and hop onto Teams into the helpline if you have any questions. See you all in the next video.